consider the problem of finding the angle between two planes. Now, if I have two planes, let's say a plane in the direction of this domino and a plane, let's go ahead and put the faces up here so we can kind of see. Okay, there's going to be a normal vector to this domino, and there's no way to prop this up. I don't have three hands, but let's see what I can do. And a normal vector to this domino. And whatever the orientation of the dominoes, we have a couple of normal vectors. The angle between the dominoes is just going to be the angle between the normal vectors. So if I bring those normal vectors down into a common plane that's perpendicular to the line of sight from the camera, we can see that the planes that I had there, the dominoes, were in planes that make this angle looks like maybe about 40 degrees, 45. Now those two dominoes didn't represent these planes, but we should be able to understand that the angle between two planes, what we mean by the angle between two planes, when we say the angle between two planes, is in fact equal to the angle between the normal vectors. So we find the angle between the normal vectors there's a C in the word vectors. That's, let's say, n1 equals 4i plus 5j minus 3k, and n2, which is negative 2i minus j plus 5k. Again, you might be in the habit of just reading off the components of the normal vector, but make sure you really understand why this does give you the components. So what's the angle between these vectors? Well, that's very easy. We just use what we know about the dot product, and the angle is going to be the inverse cosine of n1 dot n2 divided by the magnitude of n1 times the magnitude of n2. Now, I'm not going to write out all the details. The dot product is negative 8. J components give us negative 5. The K components give us negative 15. The magnitude of n1 is square root of 4 squared plus 5 squared plus 3 squared. The magnitude of n2 is the square root of 2 squared plus 1 squared plus 5 squared. And I didn't write out my inverse cosine. I'm going to smudge that in. Not sure what to do about that. That's kind of a mess. Now I'm just going to obliterate my equality and say that n1 dot n2 over magnitude of n1 magnitude of n2 is equal to this quantity here, and get rid of the equal sign. And then let's see if we can put a nickel in there to get rid of most of the smudge. And $1 down here. We're not going to get rid of the whole mess. Okay, get rid of the domino so we can see what we're doing, so that theta is the inverse cosine of this. Now, what is this? This is negative 28 over the square root of. That's going to be 4150, and this is going to be the square root of 30. And 50 times 30 is 1500. The square root of 1500 is about 37. I'm going to say that's not quite 1.5. So we're going to say that's about 0.7. Okay, actually maybe a little bigger than 0.7, 0.74. You can work that out. Okay, so theta is the inverse cosine of this. This is this. So it's the inverse cosine of 0.74. And that's going to be a little less than 45 degrees. I'll say that's probably equal to about 43 or 44 degrees. Okay, so easy to calculate the angle between the planes if you don't make mistakes when you write it down. Unfortunately, we don't have time to fix this. We're going to have to